Input validation. So often in programming, you ask the user for their input. In Python, you would use the input command. The input command, actually, sorry, the input function, right? It's got brackets. So what you pass to the function is the prompt, and then what the function will be returning is whatever the user typed in. So like a typical example is that you've got a confirmation or you need to like a menu choice or whatever, and you want to, okay, accept yes or no. And if I say Y, it's yay. Fair enough. If I say N, it's nay. But what if I say something else? What if I say blah, right? So how do I make sure that my user will get asked again? So what your intuition, I see that a lot, is to do else choice and it's do it again, right? Get the choice again if it doesn't match one of the two options you expected. That's the first step, right? But then usually students at this stage notice that actually I don't want selection. I really want iteration. I want to keep asking for the input until I got what I want. So the design pattern. So a design pattern is something where you will not use this necessarily verbatim, but you will use the structure, the pattern of this, uh, and then you can apply that pattern to your specific case. So the design pattern, you want a while loop, while not valid. So that means you want a Boolean flag. Okay, so let's just put that in with some comments. So valid equals false. I'm going to put some comments. Just okay with hash initialize valid flag to false. So we go in the loop and loop until valid. Now it's loop until valid. That's in English. It's not a do until. It's a while because we only have while. We don't have until in. Oh, I think in Python 3.11 we might have until. But if you don't want to use until, you do a while, but you initialize what you're testing on first to make sure you go into the first iteration. So valid equal false, and then while not valid. We will run this line at least once. And then in the loop, you should have the input. This is where like the input you validate is coming from here. And then you should also have work out the validity. Validity. So let's say if choice. No, I often see that. So your intuition might be choice equal y or n. You can't do that. That's not well. It's going to work. What's annoying is that it's going to work, but it's not going to work in the way you expect. I have it's an A-level type video where I explain this. Not just this, but we bumped into this into the context of another programming task. So choice. Let's have it. Let's have this like choice equal y or you can't do it. Okay, let me just show you something. Like if you do, this is Python, right? So print I. Obviously not like that. You want print with a T. This is a Python console. Now, if I do 1 and 2, that's odd. If I do 1 or 2. So the problem you have is if I do y or n, this will actually evaluate to y. I will explain maybe in a separate video. And the problem you're doing is that your choice, if you do it with that syntax, it will only check on y and no will never work. So you want your two options, your two valid options here. And then if the choice was valid, then valid equals true, which means that we are going to escape that while loop and then go and check my choice. Although that's not going to work because we're checking on y and n. So in fact, I should probably do y and n. That's the design pattern. You initialize the flag to false, so we go in the loop. You loop until valid. In the loop, you need to have the input. You need to work out the validity. You don't need more than that in the loop. This is just a loop to keep on asking until we get something we can work with. Now, because so this whole expression is a string, I can then lower it, which will make it into lowercase. um, and that's y and n. So even if I type it in capitals, let's have a look, right? So I'm in here, keeps on asking until I give y or n, yeah? But also because of my lower here, keeps on asking, but if I say no, that doesn't work. If I say capital N, boom, it does work, nay. We want to even get that even. Okay, how long I got? Yeah, all right, that's the first 5 minutes. Right, stay watching this if you want to see how to improve this even further. So just like okay, input validation, the problem is the input, right? Because the input will come from the user, and the user being a human, which is sort of soft, squishy, only works in a very narrow temperature range and doesn't really, can't really handle large currents in electricity pass through it. Humans are problematic. I would argue that the hardest part of programming is having to deal with the users or having to have your program deal with the users. So in our case, some user might be very verbose and actually instead of saying simply why, might reply yes. Well, we'd like to accept yes. We also like to accept no. How am I going to do that? Well, you remember that you can't do choice equals this or that. You have to do choice equals this or choice equal that because you want those expressions to evaluate to true or false, and then you want to do a Boolean or between those. Another way to do it when you've got a specific set of um, possible value that you want to accept is the in operator. So in, let's stop that, get back to a console. If I say, so let's have a good list. I define this as a 1, 2, 3. Easy as that, right? L, that's my list. L, you do L0, right? That's well, fair enough. So you can have the in operator. So just like you have like 1 is larger than 0, and that's true. And if you have 1 is larger than 2, and that's obviously false. And if I've got 1 is in L, that is true because 1 is in the list. 2 is also in L, but 4 is not in L. So if you get several possible valid values, you will list them all in here. So y, n, um, and then yes, no, for instance. And that's all of the possible things that we want that to be valid. And that will then accept. I mean here, and I say yes. In fact, even if I say yes, it didn't work. Huh. Let's figure out why is it not working. Because it didn't print. Yes. Oh, right. Sorry. So now we accept, in terms of the input validation, we're accepting yes or no. Um, but in fact, of acting of the based on the input, we're only acting on y and n. So what I'm going to do is I'm just going to do choice is equal to the first letter of choice, meaning that if the user has typed a y or yes or a no, it will be trimmed to just y or n. If I do choice equals choice 0, then now if I accept yes, even in caps or in mixed case, yes, then that becomes a yes. So what's happened here is that this is my input. That's my big Y, small e, big S, then dot lower, that becomes yes in lowercase. It is within the list of valid values. Valid becomes equal to true, that's going to make us leave the loop, but also choice becomes equal to the first character, it's going to become Y, which means that by the time we hit line 13, then we have choice will be one of those two things, and then we can go into our logic. That is input validation. Work at validity, the in quotes, the in operator checks for belongingness, check that the value is in the list. Yeah, excellent. That's it. This is very useful because, like, whether you get menu options or, having to confirm yes or no, particularly in your like big projects and so on, you find yourself doing that all the time. And once you get the basic building block then you'll be much quicker, because otherwise you have to reinvent it every time. So you need a valid flag, one not valid, and so on. There is another way to do this is to not use a valid flag and instead to use the choice itself. So let me just do it all over here again. So instead of the valid flag, I'm going to use choice. I'm going to initialize this to none. None is a Python. It's a Python constant, like true or false, right? And you can see it's in blue, reserved keyword, and so on. And I just mean there's nothing in this thing. Uh, so if I now use my validation, this is my validation boolean, right? If that expression evaluates to true, the variable choice has a valid value. I'm going to take this, and that's going to become the validation of my while. Boom. So I don't need to set valid, because I'm not using valid at all anymore. I don't even need you don't need to work out the validity anymore within the loop, because you can do it in the while expression. Now, this is good if valid values are fairly narrow. You can check validity quite quickly. If you say need a separate function that returns a boolean to check if something is valid, then you may want to use the more explicit version. But this is a slightly piffier. So now, because of this, I only have, within my while loop, I literally only have the input. However, just to keep dealing with yes, which will be accepted as a valid choice, but we just want to test all that, we're going to put my trimming of the choice variable in here. Yeah. Or in fact, you can probably do it like even piffier. Well, certainly piffier in terms of number of lines of code. Oof, right? So you do now, it's like initialize the input to something invalid. So we check for validity now in the while expression condition. The while condition is the validity condition itself. And then in the loop, we just the input. Yeah? And then you may want to kind of accept thing. That's your input validation design pattern that you can then apply to all sort of menu choices and things like that. This is the basic one, like when you say dealing with strings. The moment you're dealing with numbers, you're going to need to cast the input, which is going to be returned as a string from the user, as an int. And because you can't trust the user and it might not have entered numbers, I will make a separate video to explain type validation, or input validation for type. See you in that next one. Oh, well, it still went almost the full 15